All right, so today we're going to be describing quantitative data with numbers for chapter 1.3. Take a second and read pages 48 to 50. So what is the difference between this X with a line over itself and this U-looking shape? So the X with a line over itself represents the mean of a sample, while this shape, called the mu, represents the mean of a population, and you calculate them both the same way. What is a resistant measure? Is the mean a resistant measure of center? A resistant measure is a measure of data that is not affected by outliers. Because the mean cannot resist the influence of extreme observations, it is not a resistant measure of center. Just so you know, these are both pronounced mu. Take note though, the mean is sensitive to the influence of extreme observations. How can you estimate the mean of a histogram or dot plot? The best way to find the mean of a histogram or dot plot is to look for a place of balance. Let's say the light blue bars are blocks. Where could we put a ball so that it could not tip over, fall, and roll away? Considering this set of data is skewed to the left, if C or B contained our mean, think our balance ball, the ball could fall and roll. However, if we were to set the ball on A, it would not have any place to fall off. Therefore, A would be our best estimate. Take a second and read pages 51 through 53. Is the median a resistant measure of center? The median, unlike the mean, is resistant. This means that outliers do not affect this measure. The two sets of data below reflect the ages of students in a TK kindergarten class. Group 1 is just the ages of the students, while Group 2 contains the age of the teacher as well. Notice how much the mean increases with Group 2, while the median is very close to the same. How does the shape of a distribution affect the relationship between the mean and the median? Check out these graphs below. So when a graph is normal and there's no skew, with our normal curve, everything's pretty much distributed. However, when we're positively skewed, or skewed to the right, the mean is a lot greater than the median. However, when we are negatively skewed or skewed to the left, the mean is a lot less than the median. What is the range? Is it a resistant measure of spread? The range is the simplest measure of variability. To find it, subtract the smallest value from the largest value in a data set. Take note. Note that the range is a single number that represents the distance between the max and minimum values. In everyday language, people might say something like, the data ranges from 5 to 35. Now you know the statistical definition, so you have to use the term correctly. What are quartiles? How do we find them? Here's an example. I have a set of data right here that is divided up into the first quartile, median, and third quartile. So to find the first and third quartiles, you must first find the median. Quartile 1 is the median of the data, not including the median, to the left of the median, and quartile 3 is the median of the data to the right. So looking at this, our median is the very center of the data, which is 36. So to find the first quartile, I find the median of the numbers 24 through 32. Between that, the median of those numbers is 26.5. So that's our first quartile. Well, if we look at the other half, 40 through 57, the halfway point between that set of numbers is 51. And that is our third quartile. Whoops. What is the IQR, or interquartile range? Is the IQR a resistant measure of spread? Using the example above, we found the IQR. The IQR is the difference of Q3 and Q1. It measures the range of the middle 50% of the data. Take note, the range is not a resistant measure because the min and max values could be outliers. However, the IQR is a resistant measure because it ignores the smallest and largest 25% of the data. Meaning, if we were looking at that first set of numbers, the IQR would not pay attention to 24 through 26 and 52 through 57. The IQR is only concerned with 27 through 50. Here is data on the amount of fat in grams in 9 different McDonald's fish and chicken sandwiches. Calculate the median and the IQR. So here's our list. To find the median, I list the 9 numbers least to greatest and find the middle value. My median is 19. So then to find quartile 1, I look at and find the median between 9 and 19 and 20 and 33 for quartile 3. Notice to find the quartiles, I find the median of the data to the left and right side of my median. Note this is not including your median. Your median is not included when you are finding your quartiles. So to find my IQR, I take the difference of quartile 3 and quartile 1. What is an outlier and how do you identify them? An outlier is an observation that falls more than 1.5 times the IQR above quarter 3 or below quarter 1. Here is data for the amount of fat in grams for McDonald's beef sandwiches. Are there any outliers in this distribution? So, in order to do this, I'm going to have to find my median, quartile 1, quartile 3, and IQR. So again, my median is the center of my data. My quartile 1 is the center of my data to the left. Well, my quartile 3 is the center of the data, the median of the data to the right. And then my IQR is the difference between quartile 3 and quartile 1. So, let's find out. So I take my quartile 1, I subtract 1.5 times IQR. So remember, my quartile 1 is 21. I subtract 1.5 times my IQR is 8, and I get 9. I do the exact same thing, except the opposite for quartile 3. I add my IQR, and I get 41. So that means anything below 9 or above 41 in this set of data would be considered an outlier. The hamburger, 9 grams, is not quite an outlier because it lies right on the boundary, but the double quarter pounder with 43 grams is because it is greater than 41 grams. Make sure you know how to state this rule and identify outliers in a set of quantitative data. You might be asked to do this. All right. I'm not going to show this video here, but please give it a watch in the comment section. It is linked. Take a second to read pages 57 through 59. What is the 5-number summary and how is it displayed? The 5-number summary of a distribution of data consists of the smallest observation, the first quartile, the median, the third quartile, and the largest observation written in order from smallest to largest. The 5-number summary of a distribution leads to the box plot graph, sometimes called the box and whisker plot. It's shown above. These 5 numbers roughly divide each distribution into quarters. So here I have parallel box plots for the beef and chicken fish sandwich data. Looking at the distributions, we see that the beef graph is skewed to the left, while the chicken fish graph is more symmetrical. The distance to the median on the left side of the graph is much larger on the beef graph than it is on the chicken fish graph. It appears that the amount of fat in beef sandwiches can be much greater than in chicken fish sandwiches. However, it is possible for them to have the same amount of fat, as shown by the minimum values. Amount of fat is also more variable in beef sandwiches, as shown by the range. By using the IQR and the first and third quartiles, we did determine that there was an outlier in the beef sandwiches at 43 grams, while there was not an outlier in the chicken fish data. Here's a common error. The box in the box plot is not the IQR. The IQR is a number, not the box itself. Another common error is that box plots do not reveal where the modes of a distribution are. Do not describe the shape of a symmetric box plot as approximately normal. Take a second and look at pages 60 through 63. In the distribution below, how far are the values from the mean on average? I found the mean of the values in this distribution. After I did that, I listed out the values and I found the average distance from the mean. You could find this by subtracting the value from the mean. However, this distance is an absolute value. You should not have negative numbers here. What does a standard deviation measure? The standard deviation measures spread by looking at how far the observations are from the mean. How do you calculate the standard deviation for a population? What about the variance? First, you find the distance of each observation from the mean and square each of these distances. Average the squared distances by dividing their sum by n, and the standard deviation is the square root of this average squared distance. The variance is before you square root it. How do you calculate the standard deviation for a sample? It is basically the same steps. The only difference is you divide n minus 1 instead of n. This is because the mean of the sample will be slightly less than the mean of the population, so we subtract 1 to make up for it. Here's the formula you'll use. What are some properties of standard deviation? Standard deviation measures the spread in the mean, is always greater than or equal to 0, has the same units of measurement as the original observations, and it is not resistant. What are some similarities and differences between the range, IQR, and standard deviation? Some similarities are that they all measure variability, while some differences are there is resistance to outliers using all the data. A random sample of 5 students was asked how many minutes they spent doing homework the previous night. Here are the responses in minutes: 0, 25, 30, 60, and 90. Calculate and interpret the standard deviation. Here I use my formula. And I found that my standard deviation was about 34.7 minutes. The time students spent on homework varies around 34 minutes from the mean of 41 minutes. Take a look in the comment section of the video for links on making box plots, finding the 5-number summary on your calculator. I've included videos for TI-84 as well as the HP Prime.